Hello, everyone. Good morning, good afternoon, good evening to all of you. My name is Jivan Acharya, Principal Energy Specialist at ADB, and I'm the moderator for this session. And my colleague Yun Feng, he's also an energy specialist at ADB. Can I begin? Okay.
Hello, good morning, good afternoon, good evening to
Yeah.
all of you. I'm
Okay.
Acharya,
So
Principal Energy Specialist at
yeah,
ADB, and I'm the
okay.
moderator for
So
this
I would like to
session.
welcome you all to virtual Clean Energy Forum and to this session 4.2 focusing on high-level technology and innovative design for power system resilience. As we are all being affected by the COVID-19 pandemic, either this way or the other, there is no better time than now to draw attention on making power system resilience for pandemics like that. As you have noticed, we have a whole track 4 on this issue, and there are 3 sessions. One was on planning for resilient energy infrastructure and supply chains earlier today, and most of you might have attended that. Uh,
This way or the other, there is no better
Turn off
time
what?
than now to draw attention on making power
In the
system
technology
resilience.
last session, and on this track, and we'll be managing for resilience, so we could cover all aspects of making power system resilience.
Energy infrastructure and supply chain
Resilience
earlier today.
covers a
And
broad
we will
spectrum of
cover that.
issues, including proofing, climate proofing, as well as future proofing of assets and resilience, social and financial shocks may be unrelated to climate change. The fourth industrial revolution might be a more appropriate organizing principle than climate change for the energy transition. The future of technology is driving change in energy, transport, biomedicine, education, etc., at exponential rates, while planning and regulation proceed with linear rates. If it is possible to keep ahead of the curve, how can we cope? So we need to look at approaches and solutions that make energy sector, including not only the energy infrastructure, but we also need to look at utilities and companies more resilient to the changing climate, environment, and society. Advanced technology solutions have greatly changed the way we use energy and improve energy system capacity against the disaster and emergency situations. Combining modern ICT technologies with power system technologies, renewable energy solutions, power storage, and other applications enable the energy system more resilient to proactive planning, smart controlling, better monitoring, fast location, and efficient storage. So, colleagues, in this session, we have three speakers who will share new technologies and approaches, and that we'll have a short panel discussion followed by Q&A. I propose that let's have the presentations and panel discussion first, and we'll get into the questions from the participants. I encourage you to send me your questions as and when you wish throughout the session, and I will try to cover as many as possible. So now let me turn to my three presenters in the session, how to improve power system and resilience with the digital next generation community technology, 5Gs and innovation. Our first speaker, Benjamin Hope Flores, hasn't joined yet, so let's hope that he will join later. So now let me request our second speaker, Xiaoyin Yang. I hope I pronounce your name correctly, Senior Industrial Solution Manager at Huawei Technologies. She will be talking about each electric power industry ready for 5G. Over to you now.
Okay, so this is Sharon Yang. It's good to meet all of you today. Just double check. Are you all guys all to hear me well? Okay, let me continue. So let me get started here. So it's a privilege for me to have this opportunity to share with you on this topic is electric power ready for 5G. So we see that 5G is a core technology to support power grid in the next era, promoting affordable, green, reliable, and resilient power grid for all. On particular, we are going through phases along with other industries upon the pandemic situation. It's challenging, but it's also an opportunity for all. So I'd like to share with you that very recently, in the past couple of days, that China State Grid Corporation of China recently published a digital new infrastructure build the strategy plan for 2020. aims to spend about 25 billion yuan in 10 focused areas to boost, upgrade the power grid. 5G and its applications are positioned as one of the core construction areas or areas of focus for the bill. Many researchers point out the next 3 to 7 years will be a golden development phase for the 5G and expected electric power industry to be one of the key stakeholders in the value chain of 5G. So then we have the question today is that whether electric power industry ready for 5G. So I'd like to explore that question with the audience today. 5G, many of you guys it's a very familiar term to many people nowadays, and 5G is positioned as the key technology to support energy internet as a reliable and secure communication infrastructure that will hopefully provide ubiquitous connectivity for energy internet. The 5G slicing technology are being standardized by 3GPP and is maturing through pilot projects by different utilities. On the left diagram, you can see a triangle. The EMBB, EMTC, and UILC one stands for enhanced mobile broadband, and the other stands for massive machine type communication and ultra reliable low latency communication. All these three dedicated 5G slices serve different applications. As I listed a couple there, just to give the audience an insight. The URLC provides ultra low latency. On the right-hand side, the diagram, you can see the performance for comparison between 5G new radio and 4G. The latency for URLC could be as small as like as I listed on the right hand. It's about so the URLC user plane could be less than 0.5 milliseconds as compared to 4G. So overall, the EMBB, the enhanced mobile broadband, it's intended to improve the user experience and other performance based on existing mobile broadband service, mainly to pursue ultimate connection experience between people. But the EMTC, massive machine type communication, is the application for Internet of Things. Their focus area is different. It's focused on connecting things together. UILCC is intended for more critical services, such as if it is in protection, if it is in the electric power industrial, it's probably referred to the protection and control. So that is the quick introduction of 5G. And then we do see that the 5G is the standardization is being standardized. The EMBB is being standardized, and then the UILC and MTC related standard are not yet released. So this is also answer one of the questions whether the electric power industry is ready for 5G in terms of standards. The standards are rolling out, and utilities that I worked with in the past are carrying out pilot projects to test the technology. So our topic today is on the grid reliability and resilience. So we see that 5G as one of the future core communication technology will be able to support the electricity systems from generation to generation to transmission, substation, distribution. And also on the user side, our user who are changing their role from consumer to prosumers, and then they are demanding more services, and then their expectations from utilities also growing. So from all this, across all this domain, we see 5G could help bring the connectivity to all this domain. So on my topic here, on this slide here, we want to see the first thing we want to be able to provide is to provide the connectivity. The connectivity is what the first step for us to achieve a great reliability and resilience. To achieve reliability, first we need to see the grid. And our grid, dynamic of the grid, or the composition or the elements of the grid is evolving. And then the demand for communication is growing, like such as the distributed solar panels on rooftops, and then smart homes, and then also electric vehicle charging. That is on the consumer side. But we also, on the distribution side, we also have the distribution grid. Many distribution grid across the globe actually does not have distribution automation. One of the biggest reasons is the lack of investment in distribution. And then there's also status showing that about statistics showing that about 90% of the faults occurs on the distribution grid. So we see as I mentioned, the investment is one of the obstacle for us to upgrade the distribution grid, and 5G technology coming in as utilities working with telecom carriers, and then utilizing the UILC ultra reliable low latency for distribution automation. It could significantly help improve the grid reliability and resilience in the future. Okay, so as I was mentioned, that there are different scenarios, different applications could benefit greatly from the adoption of 5G. So I'll be going over a few applications and a few scenarios which with the audience today, and to hopefully to bring you some perspective, and then we can further invest the discussion into how to use 5G and how to use 5G to boost our grid reliability and resilience. So this part is the distribution automation. Just as I mentioned, in this particular case, we are talking about fault identification, removal of the fault, and then the fault and the recovery as well. So as you can see on the as I compared for some distribution grid that does not have any distribution automation, it takes a manual operation to recover from a fault, and then the recovery time can be in hours or in days, depends on the utility. Then we also have centralized distribution automation. The recovery time could be in minutes. That the status of the grid or status of the distribution network is reported back to the master station. For the future, if we are adopting the 5G with dedicated UILC slicing, it could potentially provide the distribution automation with control so that the grid could automatically recover from a fault. And this is I want to emphasize this on the fact that on the low total cost ownership, and then shared return on investment for different industry, because the 5G network might not be invested by the utilities, but a joint investment by different industries. Okay, so I'd like to share with you on the first pilot project that Huawei worked with China Southern Grid in 2017-2018, and then we sent out a report on 2019. So the China Southern Grid, China Mobile, Huawei performed line differential teleprotection field test over 5G non-standalone network, providing 5G UILC that meets the requirements of mission critical services for distribution line for applying line differential protection in distribution network. So we see the time synchronization deviations more than 300 nanoseconds, and communication latency between distribution terminal units is smaller than 10 milliseconds. So it meets the requirement for the application. I will not dive into the performance statistics here, but basically this tells you that the testing that we did supported critical services such as line differential and phasor management unit applications for wide area frequency monitoring, and then there's also security that is considered as well. Okay, well, so the other applications could significantly benefit from the adoption of 5G is the AI drones based transmission line surveillance or inspection. With the real-time live streaming from the AI drones, and then the AI edge computing on the drones, we're able to quickly identify transmission grid transmission grid defects or pre-alarmed the operators. I do want to point out here that in the older days, female does not really work in transmission line surveillance or transmission line work. And with the AI and with the new ICT technology, currently there are female workers in the China Southern Grid for the transmission line maintenance team. Okay, so next, so let's have a quick overview of the different scenarios that could benefit from the adoption of new technologies, 5G. So from the generation side, there's ancillary services could be carried out over 5G backup network. So there are existing fiber networks, and those are those still considered as the top one or the first priority for communication or the primary communication network. But with the adoption of 5G, and then as long as with affordable 5G provided co-invested between telecom carriers and utilities potentially, we could carry the many services over this 5G network. So the ancillary service is one of them, and then real-time control of distributed renewables, virtual power plant control driven by electricity market. On the substation and transmission side, that I see that we could the 5G could be a backup communication channel for dispatch and control, and that AI enabled real-time diagnosis and alarming for transmission and substation. And AI and 5G is supported drones for transmission line survey. So I do like to point out one of the case here is that upon a natural disaster, it's much easier to restore or to roll out temporary 5G stations to get the system back live, or to get the system live to be able to have a backup. Communication network. Then 5G is considered a very good option, or otherwise communication would be a very good option as well. So we do, and on the distribution side, the same here, that with distribution, we'll be able to support distribution automation, electric vehicle optimal charging control, virtual power plant to aggregate distributed small scale resources. And then, like I just mentioned, the fast recovery of communication network in case the dedicated fiber connections are down. Okay, so that is close to the end of my the presentation. That we're seeing many commercial networks are adopting 5G, and we do see that in the next 3 to 7 years will be a golden phase for all industries started embracing the 5G as the core communication infrastructure. Okay, so that is the end of my presentation. I welcome any questions.
Thank you, Xiaoping. It's very exciting to see how this 5G technology has emerged in a very short time. And of course, this is very new still for many other countries. And I'm sure I have some questions. I'm also sure that many other colleagues have also many questions to you. But now let's move on to our next speaker, who is Kyle Datta. He's the senior advisor of Ronald Berger, and he's talking about reinventing the grid for a fully decarbonized and resilient future. So over to you now.
Thank you, and good afternoon to everybody, and good morning to those from around the world, and good evening to others. I want to thank the organizers of ACEP for hosting me on this panel and having this session and demonstration of how resilient we really are. Today, I want to share with you our perspective on what happens to the grid when we really start to approach full decarbonization of both the bulk power and the transmission systems. And this is based on our work with utilities in California and Germany. And what we found is that the grid is going to face a new set of electrical engineering challenges that go beyond the integration of DERs and renewables and will require a more fundamental change in the grid architecture, essentially reinventing the grid as we know it. So why should we consider reinventing the grid? It comes down to sort of the following set of questions. Do we actually understand the disruptive impact of the simultaneous changes in both the bulk power system and the customer loads, and how these will coincide, what they'll do to the grid? Can we see the early warning signs of these happening in utilities around the world and understand the trajectory? Are there technical solutions in terms of new technologies and grid architectures
California and Germany,
in which these can be deployed?
The grid is going to
Will we be ready in time?
new set
And will technology
engineering challenges that go beyond the integration of
and will technologies be ready, and what time will they be ready in terms of deployment? And with grid modernization underway, are we laying the right foundation for what comes next? So let's talk about what drives change. So there are converging trends here. All of you are aware, of course, of climate, both the acute and climate effects,
utilities around the world,
the electrification of transportation,
Are
renewable
there technical
penetration,
solutions in terms of new
but we may not be as
technologies
aware of grid power electronics and the DER and consumer power electronics, and how these all converge into a set of disruptive trends. So we expect within about 15 years, electric grids with high renewable and power electronic penetrations will face unprecedented challenges. And I want to take you through some of these. When you have very large amounts of renewables, you run the risk of weather-related loss of bulk power, either from multiple days of lack of sunshine or lack of wind. When you start to retire your rotational power plants and replace them with inverter-based power, you're going to end up in a situation of inadequate system inertia. We've already seen weather-related disruptions from climates, whether hurricanes or typhoons or fires. And then there's three more that are more technical in nature.
We expect
Power quality pollution, as in harmonics and voltage, from nonlinear loads and inverters. Safety issues as the bidirectional flows overwhelm current protection schemes. And system stability issues at the T&D layer in both frequency, voltage, and waveform. So I'm going to get a little technical and take you through a couple of these and then talk about solutions. So this chart shows you on a time scale starting at 1 cycle to 1 second to 1 minute to 1 hour, what the duration of power system phenomenon and the kind of controls you need. What's shown in red are the three new areas of concern as we start to get to higher renewable and power loads, which are harmonics, inertial response, and short-term stability. And as you can see, most of this happens in the less than 1 second time scale. And that's important because that implies a shift in grid controls. Now, what this chart is laid out is both the latency of control response on the x-axis and the complexity of control points in orders of magnitudes. How many things will be controlled simultaneously? As you think about renewables on the system, we're going from human-directed control, where we just had to integrate renewables for the power markets and energy dispatch, and say 5 minutes to an hour ahead. We're right now trying to go to automated control, as grid modernization is. DER, regulation frequency, and that's roughly in the 4 seconds to a minute time scale. We're going to shift ultimately to local edge control. Is going to be both at the less than 1 second, but also a step change of 1 to 2 orders of magnitude in the number of control. So it's complexity and ultra low latency will be part of the control of the future. Now, turning to another issue, when you think about how these forces, one example of power quality and harmonics pollution. So power harmonics are created a combination of nonlinear devices at both the customer level, think robots and battery charging, as well as inverter-based generation. And we've seen across that harmonics in the US and Europe. And the adoption of both of these is actually starting to create super harmonics, where these waves essentially coincide to get very, very high peaks. say the 40th harmonic or beyond. This phenomenon is already in Europe damaging utility assets, such as transformers and capacitors, and starting to damage customer motors. The EU grid code, as it's being applied, actually makes utilities responsible for this pollution unless they can identify the source of the emissions and address it. The current grid sensitive control schemes aren't necessarily. Can you hear me? Yeah. Can you guys hear me okay? We're also getting a lot of feedback for some reason, not sure why. I don't think so.
The US and Europe.
Futuregrid challenges. So let's talk about solutions. So grid architectures are essentially a combination of multiple layers of the grid. And think of it as more than just the physical grid assets. There's the sensing layer, the communications layer, the cybersecurity layer, the grid control systems, the data and analytical systems. Those are the 6 layers of the grid. The starting point for this shift in architecture is the foundational capabilities. We're going to go from the areas above the layer for centralized control, low latency communication, and target operational awareness with siloed architecture to essentially distributed control, ultra low latency communication, ubiquitous awareness, interoperable data, and adaptive protection schemes. So it's going to be a very different architecture on top of the grid
Challenges.
to manage and control it.
So let's talk about solutions.
The functional capabilities on the grid are packaged in different architectural forms to address different issues. So if your issues are, say, power stability and power quality, you're going to have buffering, reconfigurability, and flexibility of both the grid and the customer and bidirectional load control. And collectively, that creates a distribution edge grid. When you have very, very high magnitude DC loads, we actually expect people to start to look at changing the grid to an HVDC and MVDC grid. And for resilience, you need a combination of the capabilities of islanding and reconfiguration, buffering, inertial substitution, and customer load flexibility. The functional capabilities are dependent on the foundational capabilities, which says the foundational capabilities, is all the IT and OT layers, have to be put in first before the functional capabilities can actually operate. There's a set of new technologies that will be needed to address these capabilities. And talk about resilience, I'm going to direct you to this chart to the far right, where if you want renewable-based resilience, you're going to need situational awareness, you're going to need localized and edge control, and you're going to need islanding and reconfiguration. That means from a technology point of view, high fidelity and ultra low cost sensors, edge intelligence based on AI for control, synchronizing protection devices, long duration storage, microgrid controllers, grid forming inverters, and then synthetic inertia is derived from that.
First, before the functional capabilities.
So why does this matter now?
Operate.
So it's important to understand something which is a common misconception. Renewables, without the fundamental changes in grid architecture, do not actually make the grid more resilient. I guess the future changes we're talking about.
To address this
What renewables do is they provide the bulk power system, make it more resilient against fossil fuel chain supply risk, and they're clearly an economic hedge against volatility. Distributed renewables with storage can provide individual customers with resilience and provide services to bulk power grids. But if you truly want resilience for the grid system, you have to simultaneously change the physical grid design and those operational architectural layers. That means you have to think about the physical grid design and segment the grid to more of a cellular mini grid design that has adequate power supply to meet the critical loads in those cells and the capabilities to manage power system stability when they separate. The grid needs to be able to dock and undock microgrids seamlessly, which requires transparency, control, and communications, as well as new capabilities. And then ultimately, for the urban systems, you're going to have edge intelligence with circuit loops or meshed grid designs to manage the system to be truly resilient. The need in the US, the need for resilience is really being driven by customer expectations of outage duration and frequency. And what we're seeing from climate change work is that when you start to have more frequent disruptions of much longer periods, then the commercial industrial customers can already start to leave. It's already economic and in their benefit to essentially self-insure due to the business losses. So all of this reminds me of kind of an old Sufi saying, which is when you light a candle, you cast a shadow, which means that really we have unintended consequences of very good policies that we're trying to create. These future grid challenges I'm talking about are the inevitable consequence of decarbonization policies combined with the advancement of civilization. We need to start to build a stakeholder consensus regarding the challenges the grid will face. And then these future grid architectures will be actually necessary for the system to operate reliably. So our journey's really just begun. We know for about 100 years, we've had a human-operated electromechanical grid. We're now just starting to go to an automated, rules-based, modernized grid. We're going to be moving over probably the next 10 years to 20 years to a partially autonomous and ultimately a network-centric, fully integrated grid, which will indeed be heterogeneous. That is, you'll have different grid architectures to meet the different needs, the different aspects of the grid, and ultimately get to the decarbonized future. So I look forward to discussing this more with all of you, and thank you for your attention.
Thank you, Carl. Really appreciate sharing your experience in terms of how the utility and then how you are introducing this kind of resilience efforts there. Really appreciate that one. So now it seems that we don't have our first speaker who I think he could not join because of some reasons. So what I suggest is that now let's move on to our panel discussion. We have two panelists today, and I have Divina Ching Kwan Ko, Senior Energy Policy Specialist, RTI International. She will be focusing on the high-grade technology in aid of a smarter grid. I think she will also giving some examples here. And then I am also pleased to have my colleague Noel O'Brien. She's a Principal Climate Change Specialist in ADB. So let's have a kind of a short but a very focused panel discussion with both of them. What I suggest is that I will request both of them to make initial remarks, what they have heard and what kind of reflections they have or any other ideas they want to put forward. And after that, we can have a few question answers with both of them. But I suggest that Divina, can you start first, please?
Yeah, thank you. Thank you for inviting me here. Like, it's very interesting to hear the 5G technology and what Carl is introducing. And the Philippines has also started doing smart grid, but there are 142 distribution utilities across the Philippines, and they vary from size, the load of nature, the nature of their load. And as Claudine said, is the distribution utility or the electrical grid ready for 5G? I guess it varies. I'd like to introduce our partnership with the U.S. Pacific Command, wherein we try to introduce higher level technology in order to equip distribution utilities to be able to monitor their load and determine whether there would be force outage and avert or intervene in order not to do that. So can you see my screen? So on the left would be like, it's a partnership between the US Pacific Command represented by Dr. Steve Chan and Stephen Frano. And this is a pilot with the Bohol Light Company. And on the right would be our partners from the Department of Energy and the Palawan Electric Cooperative. So basically, the US PACOM team or the Unified Cost introduced what we call Edge Diagnostic Analytics Visualization System. And the intent was to provide or equip the DUs real-time monitoring of power supply. So it's almost similar to what Kyle is saying, that it would be a continuous streaming of big data so that the DUs can better understand load variations and then determine whether they would need to intervene in order to avert power shortage. And for us, it's a determination whether the technology is applicable to one distribution utility or better equipped to a bigger utility. But the intent was for the DUs to start enhance monitoring capability in order to improve operations with regard to stability, reliability, and resilience. And this is basically what the technology can produce, assuming the DUs can understand or interpret what the data is. And that's what the US PACOM was trying to do for the two pilot utilities, DLCI and Paleco. So basically, we basically said that the quotation is for the DUs, you've got to understand what is normal first, because before you be able to understand what is abnormal. So it basically ties up with what we've heard from Kyle, and I guess the 5G technology is, I can tell you probably, it's not something that a lot of distribution utilities in the Philippines are ready for. So thank you for your time.
Thank you. So now let me move on to my colleague from our Pacific department. So would you like to give your thoughts or some reflections what you have heard so far?
Thank you, Jiwon. Can I just confirm that you can hear me?
Yes, we can hear you. So please proceed.
Okay, so I mean, from our perspective in the Pacific, obviously these are really interesting and exciting developments. This whole question of the reliance, the resilience of the grid, and all the associated technologies from that Kyle has shared with us, and also from Davina. But then also the whole question of 5G and how the electrical system can support it around the world and in ADB countries. I mean, for us in the Pacific context, I mean, these are obviously kind of visionary context in the future. We have to remember that in countries where we're dealing with levels of fragility and vulnerability, that there is a need for differentiated approaches, and how some of this technology will be relevant, but in other contexts it will be a part of really the foreseeable future. You know, if I think in the context for some of the countries in the Pacific now, the new undersea cables that are being installed, they are bringing increased connectivity, but not prepared yet for the 5G context. You know, we in an earlier session this morning, we talked about the need for private sector engagement, but the question is about the affordability and what scale do we need to operate at to be able to bring in these newer technologies, and how can we do that? You know, particularly in the kind of contexts where we're faced with these existential threats for countries, the atoll countries like the Marshall Islands and Kiribati and Tuvalu. You know, on the other hand, I look at how the technologies addressed today, but also other technologies can contribute to harnessing the data that we need to make the systems in the Pacific countries more resilient. How do we do that from GIS-based data for the electricity system and energy systems, but also for all layers of data, from basic hazard data through to exposure and vulnerability, and how do we layer these? How do we work together? How do we share data? How do we work more collaboratively to ensure that our systems have greater synergy? And so, I mean, so as exciting as it is with new technologies, we are, you know, as an institution, ADB must, we're also working at differentiated levels. So Jiwan, I think those are some of the thoughts that come to mind initially here today.
Thank you, Noel. Now I wanted to go back to Divina. So now you took example of Philippines, of what we have done and so on, but you have also heard about audio presentations also. So how do you see the replicability potential of what has been done in China and also in Hawaii and the US and other places to, in the Philippines? But at the same time, you also heard Noel talking about the situation in the Pacific countries, and also Philippines being a Pacific island country as well. Of course, we are not dealing with one entity, one utility, but there are, you know, numbers of those utilities as well. How do we identify which technology would be the ideal for these utilities, and how do we go about it? Any reactions in terms of what we have heard so far, please?
Yeah, the Philippines has smart grid technology roadmap, wherein it comes in phases. So as I said, there are 142 distribution utilities, and they serve different purposes. Some are very big and some are very small. We have 7,100 islands, and I agree with Noel that it has to be a differentiated approach. But first of all, I think communication infrastructure has to be resolved first. It has to improve in order for us to really bring in the technology that we want, the technology that we introduce for 2 pilot distribution utilities. So it's, and as you know, we are also a highly vulnerable country, like not just for climate change, but armed conflict. So these are two different, very various situations that we need to deal with. And we've got to understand where the technology is available and applicable. But mostly for a country as developing as the Philippines, it's really an issue of cost too. How much will it cost the industry to be able to like adopt, upgrade, and then pass on to the consumers? The Philippines passed the EPIRA, or the Electric Power Industry Reform Act, where ideally there are no subsidies. So it's a 99% driven by the private sector. The government doesn't really want to provide subsidy, and it's how the private sector is leading. But as I agree, we have to choose where that technology is applicable, or be very cautious on how we upgrade from the phase 1 of the smart grid technology roadmap into the 5th level, as Claudia was saying, it's like the self-healing grid. And for me, like, technology displaces human people or employment. How many millions probably will have to re-engineered, or might even lose their jobs because technology has taken over their jobs.
Good. Thank you for that one. So can I also now invite our other speakers also, so that I can also see them and have a little bit of a chat with them as well? Good. Thank you. You know, we'll go into this cost aspect a little later, but you know, since this is a technology focused session, what is very important is this security aspect of it, you know, because we are introducing these new technologies all the time. And then, of course, if you talk to the technology service technology providers or service providers, they will always claim that their system or their technology is very robust, is free from any problems and so on. But before we introduce such, how do we ensure that safety and security, especially on the security side of it? How is our Huawei's experience? Any thoughts you have on this particular question, please?
Yeah, well, I think it's certainly true that utilities won't go forward with the next level of device technology unless it has passed cybersecurity for all the right reasons. And so I think it really is a gating function. I called it out as a specific layer of the grid architecture that sort of, and it really will function like that. There's the need for cybersecurity as we start to move to more and more integration with the customer becomes harder and harder because there's fewer and fewer standards at the customer side, right? So you start to go to their devices, they're easier than the utility side. But I think it's an absolutely critical question. It probably will be the gating factor that slows some of this down.
Good. How is it from Huawei's perspective? Because you also mentioned about these 5G technologies and so on. How do you ensure this safety, security, especially the security aspect of it, please?
Okay, so in my perspective, the security requirements are evolving, and then it's growing. That's for sure. So we take on a pilot project kind of approach to the industry. Work with our customers to understand their regulations, understand their requirements, and then with this in mind, we work with our customers on cybersecurity design.
How do you, one follow-up question to you is that how has been your experience, because you have also mentioned about your work with the South China grid and so on. How has been your experience of introducing these 5G technologies with them? Was it been a little bit easy for them, or was it also very kind of a learning curve? Was it still challenging there?
Okay, so in terms of experience, so there are pilot projects carried out that I work with State Grid Corporation of China and China Southern Grid mostly, and other utilities are exploring and then in the phase of designing. So in terms of experience, because our project has been mainly focused on ensuring the critical performance, met the protections and the control applications for the China Southern Grid, and there's other scenarios that we planning out that will carry out 5G pilot projects. So I have to say that the cybersecurity part, because the 5G is only the communication channel, and there's many security related to the applications security. There's also IP or TCP kind of communication encryption. So there are many industrial cybersecurity requirements out there. It is true, we are in the phase of planning, so I have to say that that really depends on the customers. Like the China Southern Grid, they have basically they separate the grid protection and control into domain or like into different control zones. So they have 4 control zones, and then they are horizontally for each control zone, or for each zone they are physically isolated, or only traffic goes one way. So there are those kind of security regulations that we are working with our customers to fulfill their existing requirements. At the meantime, also adopting cybersecurity requirements that is applicable to the consumer market.
Good, thank you. Now I move on to our experience from Hawaii as well. I mean, how is this artificial intelligence going on in all of these things? Would it be, how it is helping or making things more complicated, or what's your experience there?
So, part of when we say distributed intelligence, going beyond sort of rules-based automation, that really is part of the artificial intelligence technology wave. And so there's a future kind of state where you end up with, if you will, smart, intelligent devices and switches talking with other intelligent devices, and really making decisions at very, very short periods of time, very low latency decisions on the edge, because the grid itself has been wired to be flexible. So they have that ability to make a set of, if you will, policy-based decisions. And that's kind of where it's heading. So the computational power and the ability of machine learning to understand its area of the grid and then how to respond and manage it is, I think, part of the future. And it applies in the same way that microgrid controllers apply at kind of a smaller scale, which actually brings up one other point which I want to address based on what Noel said, which is the perspective of we're trying to share applies equally whether you're a very high-tech urbanized system or a very more appropriate tech small Pacific island. Of the same work we've done in Puerto Rico, for example, around resilience. It's really about thinking about it from an architectural basis and saying, look, if we want to get to these high levels of renewables and high levels of electrification, how do we change the architecture of the grid? Don't assume we have to stay with the same architecture we've had for 100 years. It's the time to start to really think about how do we change the circuits? What are some of the devices we can put in at the right level of affordability so that the system will actually work at the levels of renewables that we all aspire to.
Yeah, no, I think, I agree with you that on one hand, we need to continue introducing these new technologies. And now, of course, we always come across this kind of pandemics and we need to make our systems resilient so to these kind of external shocks. But you also made a good point about how to bring in more renewables into the system, and that also, affects some kind of system stability issues. So this is where we can, how these our advanced technologies, whether it's a 5G or any kind of AI related things, we should do that one. I'm also started getting a lot of questions from our from the audience who might be listening to us, and again, I encourage all of them to start sending me their questions. Please don't be shy to ask questions, and then also don't be strong enough to ask the difficult questions. Let's say, because we have lined up a very good speakers covering various aspects as well. So let me start. The one question here is about this policy and regulatory challenges and in implementing these kind of interventions there. Divina, would you like to start? Or I can also invite other people as well. But what do you think of this? I mean, the policy and regulatory challenges of introducing all of these things. Yeah.
There's really a lot of policy. We have the Department of Energy laying down the policy for smart grid technology roadmap. Regulatory would be a different part because it has to balance the interests of the consumers and the investors. So our regulators are independently set up under EPIRA, but they have to consider a lot of different issues that they face, and they are mostly for consumers. So it's really trying to develop a regulatory framework that one would really attract the private sector to invest in the kind of technology and then be able to recover their costs. But at the same time, how would now these people be able to afford its cost? So normally you would do a cost benefit analysis on which distribution utilities can really start doing this. And there are 120 electric cooperatives. More than 20 of them are in off-grid areas, and probably it would take a long time before this move on. So we're now going to see the cities first, or the Manila Electric Company, which accounts for 60% of our load, to start looking at the kind of technology that we're trying to introduce under the U.S. Aid and U.S. Pacific Command Partnership, the same way that Kyle was saying. We're bringing in a lot of renewables because we have a Renewable Energy Act, and we're very aggressive in order to build our energy security. We are an archipelago, and we have no neighbors from which we can borrow power. So we have to really doing a balancing of our grid. So, but it will take time. A lot of policy incentives, and regulation. That has to work.
I think policy can also be a forcing function. I mean, if you think about if the experiments and pilots are going on for peer-to-peer energy exchanges in Bangkok and Malaysia were to actually be enshrined in policy, then the grid operators have to, of course, make that work, which would be a tremendous shift in the technologies they would have to be able to manage and monitor those kinds of exchanges. So it can go in both directions. I totally agree on affordability, but also sometimes policy can force the grid operator to do different things.
And I agree with you, like what drove renewable energy were mechanisms like the National Renewable Energy Program, the RPS, which mandated distribution utilities to source a certain percentage of their power supply from RE, and the mass run dispatch of renewable energy. So during COVID, I understand it was renewable energy that was really like driving the grid because demand was so low, but they have to be dispatched as they ran.
Noel, I want to come back to you on this question of policies and also other regulatory things, because you are also covering these various small island states of the Pacific. I mean, there are already many other challenges that these small countries are facing, and then when we are trying to introduce this kind of new technologies, what kind of challenges that you see in those countries, and then what can be done? I mean, on one hand, these technologies will offer a lot of advantage for these island countries. But on the other hand, they're already grappling with so many other things. How do you see these challenges in those countries there?
Thank you, Jiwan. And part of my response will probably be a question to Kyle, because he's mentioned his experience in Puerto Rico. I mean, for many of the Pacific SIDS, as you know, I mean, just capacity is a major challenge, and that is capacity just even in terms of numbers of people. Where in some circumstances we will have the government officers who will hold a number of hats because they will be spread across a number of divisions within ministries, or even sometimes a large ministry grouping. So this really is a challenge. I think also that question about private sector, sometimes it's about providing parallel capacity almost, where even for ADB projects alone, you're bringing in staff, you're providing staff or contractors to the PMUs to support the project implementation. So I mean, I would be really interesting in hearing from Kyle on their experience with the Caribbean small island states, and how the technology is also enabling capacity building. Because these, as we can see now during COVID, we're all working in a totally new way. We're gaining collaborations. We're certainly working with our Pacific partners in ways that we didn't do before. So how can we loop this in to kind of increase the capacity and further build the capacity of the current teams?
So thank you, Kyle. Would you like to share some of those examples of other countries?
So I think in part, a couple of observations. So, as the island nations who are on the front lines of sea level rise start to embrace, more renewables because they want to be contributors to the system, I think there's a couple of interesting effects. One is actually you have a new generation of engineers that are excited to be part of those utilities. And it's actually really interesting to see the generational shift that's occurring. And I think that's one of the avenues where you have the opportunity for kind of capacity building, people who are willing to kind of rethink how the system could work and why, not necessarily sort of feeling challenged by the old ways of doing things because they are sort of new coming into the system. And there's a tremendous opportunity to intervene at that moment in time. I think all of the systems in the islands benefit from the more cellular architectural approach. I mean, we built most of our islands with kind of radial lines looping the islands that are so fragile and so easy to break from so many different disasters or, suicidal geckos, for crying out loud. That as you start to really think about redesigning the system to a more cellular basis, where you're putting generation closer to loads, more buffering and storage, and then making sure the electronics work within that system, that's a real different way of doing it than the old radial diesel-fired or LSFO-fired plants that sort of sent power around the circle. So from a capacity building perspective, I think there's an opportunity with the renewable transition to build the next generation of engineers, in essence. That's what we're seeing.
Yeah. Good. Thank you. I want to come back because I saw several questions coming from our other audience participants. Is it really worth investing in the 5G for these countries who are already have so many other challenges? They even probably don't have a basic internet facilities there, and then now we come up with 5G, which is so advanced, so sophisticated, so expensive. Huawei, I mean, you have, of course, you have promoting these technologies. I mean, it has a great benefits also. So I'm not questioning that part of it. But is it for every countries? Or shall we, this one is still a dream for many of our developing countries who are still struggling with the basic internet facilities or basic communications facilities there. So how do you see from the service provider or technology provider point of view?
So I would definitely put this into different categories. So there are countries who are still building up their bulk electric power systems and then building the basic functions and meeting the basic electricity demand. So for those, yes, invest that into the power grid itself first. And then also could do pilot projects along with the telecom industry. So that is for that. And then the second, if the power grid is in good shape, you're meeting your demand, and your society is your country is adopting 5G. Like you do not, like, say that if you don't have cell phone signals, you're not investing in 3G. Most likely you're going into 4G, jumping from 2G to 4G, or jumping from nothing to 4G. So same here, maybe in another 5 years, you could be jumping from 2G to 5G. It's a gap. You don't need to go from 1, 2, 3, 4, 5 to the 5th. So that is one of my opinion. And then the investment, the putting down 5G as the communication infrastructure is costly at the front end. And then we do see that it takes more than just the electric power industry to invest. So that's why we're seeing utilities like even SGCC as one of the world's biggest utilities. They are also working with carriers in China. One say that they're lending out their transmission tower as a tower to hang 5G radars or 5G radios, so equipment. So it's a collaboration between utilities. I see this as it's costly. Take it as an opportunity and then work out a certain kind of business model between different industries to make the best out of the technology. And then also upon the fact that we do need some stimulus for our economy, especially after this pandemic. So that would be my quick answer, is that looking to your country's current status, and also looking to working with other industries to put down this to consider this investment.
One, I mean, you answered it very accurately and also diplomatically in terms of how do we handle the situation. One follow-up questions to you is that you partly also covered it in your presentation, but where do you see in terms of the cost going down in the next year or next 2 3 years, next 5 years or next 10 years? Of course, all these communication technologies are changing so rapidly, so it's very difficult for anybody to even imagine all of this, how the situation would be in a few months or in years. But what's your perspective in terms of how the cost will go down and how the coverage would that be in the next few years?
So I don't have a specific timeline, but I would say that definitely the consumer market or the electronic consumer market from putting down the enhanced mobile service for our cellular for our phone users, and that will drive the market of 5G. And then upon UILC and EMTC slices rolling out and then being standardized in 2022 or 2023, then we do see that there will be more steady investments into 5G and large scale deployment. What we are seeing right now with utilities is more along the line of the transmission, say that the transmission line pilot projects that live streaming via 5G. And then there's also robots in substations. And then there's also the distribution automation pilot projects for 5G pilot projects using 5G. So we would like to see a large scale of a pilot project first to gain confidence for utility to gain confidence and then to understand it first. And then I think in the next 3 to 7 years, we do see a big boom, more than just for the electric power industry, but also for manufacturing and for other industries.
But now, thank you. Now let me move to Divina. So let's say, Divina, if you are a head of, let's say, Department of Energy here in the Philippines, or let's say you are a CEO of any utility here, of course, you have a lot of challenges to make sure that the system runs and then people get electricity and so on. But at the same time, you need to get prepared for this kind of pandemics. And of course, Philippines, there are a lot of typhoons and so on. There's other weather-related challenges as well. So would you go for 5G now, or will you wait for a while? Or what will be your considerations moving into a kind of advanced technology? And here I really like to emphasize the point of leapfrogging, because we don't need to go into the same development path that others have gone through. So if you can afford, or if you can move to, let's say, jump into from 3G to 5G, instead of going through 4G, for example, or from 2 to 4, whatever that be, how would you consider those opportunities or challenges, let's say, in your case?
Yeah, just a comment though, like there's actually a debate among like senior people like me in the industry, and the question is, why even go to automation if you're gonna face cybersecurity? So, but the point is, and it's not wrong to consider what technology is out in the market, but then you have to take cautious steps, differentiated approaches, and try to make sure, like when you leapfrog, you have a holistic overview of what's going to happen, what needs to be done from government, both the DOE and the ERC, what the public should know, what the Ds should know. And then for me, it's an entire community of stakeholders, players that would make things move forward. But it will always be a slow approach, a gradual approach, because as you said, we're faced with so many problems, not just climate change. Now we have the ISIS. Now we have to look at pandemic and how we're going to recover. For a country that exports its people, like a lot of our GDP, or probably 10% of our GDP, is contingent on overseas remittances. And now these countries are actually also experiencing the same experience that we're experiencing post-COVID. So it's trying to prioritize where we want to go, and it's trying to make sure that, oh, we know that that technology is out there in the market, but we're not ready for it. So we will try to put the platform of or the framework, the policy, regulatory, as we move slowly towards that kind of technology. But hopefully, when we reach that stage, there's another upgraded technology out there that we need to catch up. So that's coming from me, born in the Philippines and worked in the sector for 38 years and work in the international community too. So
Yeah. Thank you. But I do have one follow-up question to you is, of course, we can wait and see whether the cost come down, whether this technology is better, whether automation is better with this or that. The question is, are we losing time or are we losing an opportunity here in terms of making a faster or let's say prompt action and then benefit out of it, rather than waiting, or maybe we may be losing for while waiting for this? Shouldn't we be acting fast, more proactively to push for these kind of technologies and leapfrogging?
yeah, actually, for me, it really depends too. Like, we might be losing time and the opportunity. But then there would be like big distribution utilities that would probably leapfrog, and they did their market assessment. They did their market intelligence. Our sector is not driven by the government really, because the government does not invest, but it's the private sector that does it. But no matter what, how much interest of the private sector is, they would need the regulatory framework to do it. So we still need to put in place a regulatory framework for distributed energy resources, advanced net metering. But most of all, it's also capacitating the people that's gonna lay down the regulatory framework. So I agree, we're losing time, but it might be time wasted too if we like approach it without caution or without differentiating on which technology would work best. Is it just Metro Manila or Cebu City or Davao City? So we're doing pilots. If you're an electric cooperative, probably it will take you a lot of time because you have the obligation to serve and you have like long distances to extend your lines, but very few load. So it would probably be the cities that will drive this.
Right. Oh, good. Thank you. I received lots of questions related to financing. So I think, we being a bank ourselves, ADB, and then my colleague Noel is there. So I think she would be the right person to respond to these financing questions. These technologies are good. We are supposed to promote these leapfrogging of technologies. Countries lack capacities, they lack awareness. They need to make a right decision in terms of what is the appropriate technology for them, whether any kind of communications or resilient technologies. This all would need money. Some would be in the form of, more like a technical assistance, some more like an investment side of it. What is ADB doing, or what ADB is supposed to do in these areas? So Noel, over to you, if you can shed some highlight on that one, please.
Thank you, Jiwon. We look at obviously at ADB's countries from the different perspectives of our category A countries that are grant recipient countries, to right across the spectrum to those that are only loan countries. And then it's obviously the question of prioritizing. We've had a growth area in the whole renewable energy sector in the Pacific. It's still obviously much more expensive at a cost per unit of power than in other parts of the world. It does obviously bring greater resilience. It contributes to the decarbonization. But then we then come to the question of prioritization. So now, obviously, with COVID, the recognition that there hasn't been so much investment in social protection, in the health sectors, and so you will have a transfer, you will have greater focus. Obviously, for the Pacific countries, ADB's budget has grown very significantly over the last 6 to 8 years for the Pacific countries. So there is a total greater dollar investment, but now it's obviously that question of where will the countries prioritize, and to what scale do we have to invest at the sovereign level before the market is established to bring in the private sector. And that obviously, again, varies from country to country, from both the state of development, but also from the perspective in terms of population. So, you know, those are factors I think that we need to consider. Obviously, ADB also, we have our Asian Development Fund, we have co-financing, we have a number of trust funds, and we have through those we have technical assistance, which supports investment, supports work at the policy level, and supports the countries to pilot interventions, and also to invest a lot more money in the actual project preparation stages, which are all a major part in building the capacity of countries. One question I want that comes to mind for both Huawei as a company, but also for Davina and Kyle, is obviously, when we look at the current situation, you know, when we have children who are all required to be educated, we're looking at the Philippines question. How do we educate? How do we ensure that the gap does not grow? You know, because I feel although countries may not prioritize these investments, we run the risk that the gap will grow, because without the latest information and the power to generate that then we are building on the challenges. So I think it would be also interesting to hear a little bit from that perspective. Thank you.
Yeah, thank you. So Kyle, one question to you is, by the way, we are also almost done with our available time. And then before I wrap up, I will also be asking all of you to make your final 1 minute comment, advice, or one message, let's say. So please start thinking about it. But Kyle, two questions to you. One is about this private sector participation, and of course, governments are overstretched with so many demand of their limited funds and so on. How do you see private sector getting into more of a service provider point of view, and then let them make the investment? Obviously, we need to have a proper regulatory framework in that particular country before any private sector can come in. So let's assume that the governments come forward with the enabling environment for that, with appropriate regulatory regime in place. Are the private sector ready? Are private sector are already doing a lot, or what do we need to do so that we can attract them? That's one question to you first. Why don't you share your thoughts on that? How to bring in private sector, basically.
So for the grid, in specifics, we're talking about the grid and resilience. So
yes.
If you lay the predicate that we both have fair regulations, the ability to earn a return, and protection of intellectual property, those two things are givens. I don't think you see a problem of capital. The capital is there. It's a risk-return relationship, and I think that the challenge of ADB is, as you're in the more urban, industrialized areas of Asia, you have a lot of capital coming in. There's a lot of foreign capital, a lot of country capital, a lot of private sector interests, a lot of global trade despite COVID and its repercussions. I think where you get to the harder challenge is as you go into the areas Noel was talking about, where you go to smaller areas that have weaker economies, smaller communities, getting private sector to come into there is hard because, you know, unless you're supporting sort of the natural resource aspects of that area, there's, you know, not the economic returns for the risk you're taking, the credit risk alone, right? And that's just the reality of sort of capital. And I think that's where you have to have hybridization, right? In other words, if you're getting good returns for the credit risks you're taking, capital does flow, as long as they believe that the countries aren't going to expropriate their monies or someone's going to steal their IP, capital does flow just fine. It's that middle bar that we care so much about as ADB and of course as Asia, that we need to think about how to essentially underwrite some of the risk, whichever way you do it. You can underwrite it at the credit level, which is cheaper, or you can underwrite it as subsidies, which is I personally think is more expensive.
I mean, what you said is correct, but at the same time, you know, in ADB also, we always say that, you know, money is not a problem. If you have a good project, if everything is ready, then money will come, either from ADB or from other local banks and others. So we also say that, don't worry about money. Make sure that your project is good. And all the other terms and conditions are right. Then the money will come in from anywhere. But at the same time, getting those conditions, preconditions, I would say, getting those right. That's what we don't have in many of these countries, and it will require a lot of efforts to make those things right. And by the time when those get things right, then probably, then we don't need private sector because they'll already be there. So now the question is, we have this situation where the things are not 100% right. But that's the time when we need to attract. How do we do that?
So think of it this way. You know how important energy access is in terms of you need lights, you need communication, you need your cell phone, you need the internet, you need all these things. You can't do that without supporting microfinance and microcredit, right? You have to have that other side there too. So we have to think beyond our little sector of energy to say, yeah, we want these things. We all know they're important, but we need if you will, the financial sector support as well, which is really around, again, credit to allow access. You put the two together, you're going to have a system that can have access, right? And then, of course, it opens the door to education. It opens the door to better pricing, fair pricing, a lot of things, right? So I think it's maybe a little bit of, this theme of this conference was cross-sectoral thinking. I think part of this, the answer to your question really is that cross-sectoral thinking, in my humble opinion.
No, it's good. Thank you. Some of you might have attended the opening session yesterday, and one of our director generals, he made a very good point, and he said that now we are all dependent on either Zoom or MS Teams or any other platforms for our communications, for our calls like this, and so on. And then if you ask people what is most important, now everybody says that, oh, internet is the most important right now. We all believe that's true. But nobody talk about, electricity itself. If you don't have electricity, you will not have any of those things. So, I mean, the basic foundation is that we have to make sure that there is a 24/7 reliable, affordable electricity supply. And only after that, many other things happen. And of course, you touch upon this energy access issues is very important there. So we are kind of almost done with our time. So what I suggest is that I will ask each of you to give maybe a 1 minute for your final thoughts, especially on your advice to the people, to the participants and others. How shall we move ahead from here? I would like to request you to keep in mind that whenever there is a crisis like this, and it's also an opportunity for us to think outside of the box. But oftentimes what also happens is that we talk about these new tools, new requirements only when we are going through a pandemic. And once the pandemic, let's say, is over, then we kind of forget about it, and then we move on to our normal business as it is. So right now, COVID is going on, so everybody's talking about pandemic. Even in our SF this time, we have so much focus on this pandemic. Everybody talks about it in every session. We discuss about it. I mean, this is an opportunity for us to build that resilience, required resilience in our energy systems. But at the same time, we should not forget once, let's say, once this COVID is over, and then we go back to our normal business as it is. So we should not forget that one as well. So keeping that in mind, you know, I would like to request all of you to make your final 1 minute remarks there, and then we have about 275 participants listening to us this conversation. So I would like to, you know, so that you'll also get some final messages, takeaway messages, let's say, from you. So there is no particular order. Anybody wants to go first? Okay,
I'll
so
go first.
yeah,
Um,
Divina, please go ahead.
Yeah, I'd like my last message would be related to Noel's question. I think we cannot stop technology. It will come. So it's preparing the new generation that would basically breach the generational gap. But by the time the technology arrives, they are ready. And the Philippines just, you know, like reinventing their educational system. Now we're matching the kinder to 12 because we realize we have to prepare our youth for the coming generation.
Thank you. Who wants to go next?
I'll go next. This is
Yeah,
Chuck.
please. Yeah.
My message will be say that the pandemic is a challenge, but it's also an opportunity. I do see that the new ICT or ICT technology will accelerate the process to get us into new norm. For all the folks online, I would probably leave the message saying that consider what is ahead of us and what will be the new norm, and plan for the new norm. You can think about it, make plans.
Thank you. So Kyle, you want to go next?
Sure. My message is that decarbonization is an imperative. We live in one planet. We don't have a spare. And at the same time, we have to also make sure that those systems are resilient against climate risks, terrorism, disease. And I believe technology has an important role to play in terms of making that leapfrog, accelerating that change in a time frame that's meaningful. But it's going to take a lot of collaboration. I think one of the messages that I want to make sure I leave with is that no single utility, no single actor in this play can do it alone. It's really going to take all of us working together to bring in this new grid, this new energy system, this new communication system. It's a group effort.
Yeah, thank you. Noel, you want to go next?
Thank you, Jiwan. From the perspective of ADB in the Pacific, we're working on the new strategy for the Pacific SIDS. It's our Pacific approach, 2021 to 25. Resilience will be at the front and center of that strategy. I mean, I see that at a number of levels. It's obviously how the total resilience of these communities are developed in a holistic way. And obviously from the energy sector, how do we work to make sure that we are putting in place the most resilient systems that can be made available at an affordable level. So thank you and thank you to the participants.
Okay, yeah, thank you. So I think we have 1 final minute left in our session. So I also like to take the opportunity to thank all of you for your excellent intervention and participation, and of course sharing your views on various topics. And of course, you know, there were many questions from our audience. I could not take those fully, but I'm sure this is just a beginning, and then we all can, you know, continue our discussion in these areas. I would also like to thank all the 275 participants who watched us or watching us for their interest on this one, and again for their support and cooperation as well. And I would also like to thank our organizing team, my colleague Yong Fing, and also all other colleagues for putting all of this together. Thank you, and then stay safe. Thanks a lot. Bye.
Thank you.